Hello everyone. So today we are going to see about module 3 Z transform of chapter 2, that is module 3 of nothing but M3 is nothing but transform calculus and Fourier series. So today we are going to learn about to obtain the Z transform of cos and theta and sin and theta, and with the help of the Z transform of these two we are going to find for k power n cos and theta, k power n sin and theta, and this and this. Okay, so let us go on with the first step. So we already know that e power I and theta is equals to cos and theta plus I sin and theta. So e power and theta is equals to cos and theta plus I sin and theta. So we can write our e power I and sin theta in terms of e power I theta whole power n, which is nothing but k to the power n, right? So e power I n theta is nothing but e power I theta whole power n, which is equals to k power n. And also we know that z transform of k power n is nothing but z by z minus k, which is also nothing but in place of k we have e power I theta, so that's nothing but z by z minus e power I theta. Okay, so after this, so what we are going to do is, so I will write the same thing again, z by z minus e power I theta. So this has a whole term. So I'm gonna multiply and divide z minus e power minus I theta by z minus e power minus I theta. So here divide and multiply. What is this? Z minus e power minus I theta. Okay. So after this, what I do? So keep it as it is. So e power minus I theta. Here we know e power I n theta is cos n theta plus sin n theta. Here n is nothing but 1. So it's nothing but z into z minus is of minus. So e power minus I theta is nothing but cos theta minus I sin theta. Here there is no n because the value of n is 1. And then it's whole divided by. So when we multiply this and this, z square. So z into this, that is nothing but minus z into e power I theta plus e power minus I theta plus 1. So here, why is this and why is this? Let me tell you. Okay, in this, so z into e power minus I theta is nothing but z into minus e power minus I theta, and e power minus I theta into z is nothing but again plus of z into e minus e power I theta thing. So z into z is z square. Z into minus e power minus I theta is nothing but z into this, and minus e power I theta and this. Okay, in this who is common? Z is common, and also the minus sign is also common. So I'll take this outside. So minus z of this left e power minus I theta plus e power I theta. The same thing here. Okay. So why is 1 here? So when you multiply this and this, there's nothing but minus e power I theta into minus e power minus I theta. So the bases are same. Okay. So what will happen? So minus into minus is plus e power I theta into minus I theta is nothing but I theta plus of minus I theta. As we know, e power m into e power n is nothing but e power m plus n. So when we do this, e power minus I theta minus I theta, which is equals to e power 0. Anything to the power 0 is 1. So this is the thing. So till now you got to know what it is. Now let us go to the next step. So let me erase all these things. Let me write the equation that we got last time. Z into Z minus e power, okay, sorry, Z into Z minus cos theta minus I sin theta whole divided by Z square minus Z square minus Z square minus Z into e power I theta plus e power minus I theta plus 1. Now here we can see that e power I theta plus e power minus I theta. So what is e power I theta? It's nothing but cos theta plus I sin theta. In the same way, what is e power minus I theta? It's nothing but cos theta minus I sin theta. So when I add these two equations, that is cos theta plus I sin theta plus cos theta minus I sin theta, it's nothing but this and this gets cancelled, plus is this 2 cos theta. So in place of this, I will write it as 2 cos theta. So now what I will take, this as a whole thing and this is separate. Okay, Z into Z minus cos theta minus I sin theta whole divided by Z square minus Z into 2 cos theta plus 1. So this is our step. Next, now we take this as a real part and this as imaginary. We always know that I is an imaginary part. Without I, this is all real part. So I separate these two. That's nothing but. So real part, that's nothing but Z transform of the real part, that is cos and theta, is equal to the real part of this is nothing but Z into Z minus cos theta whole divided by this whole thing. Z square minus Z 2 cos theta plus 1. So Z square minus Z 2 cos theta, these are the real part. So this is the imaginary part, that is nothing but Z transform of sin and theta. So this sin and theta is equals to what's left, Z into this, Z into sin theta by Z square minus Z into 2 cos theta plus 1. So this is the real part and this is the imaginary part from this. Okay, end up in this? No, right? Okay, let me know if there's any doubts in your comment boxes and you can comment on this. Now we got to know about cos and theta and sin and theta, right? Now for this and this, let me solve for these two. Okay, with the help of these two, you can easily get these two. Okay, let me keep the equation aside. And k power and cos theta, we know k power and sin theta, we know that. So damping rule. So what is damping rule? Here is Z transform of un is equals to uz of z. So this is our damping rule. So when we add Z transform of k power and un, then it will always be z by k. Now q power z. Okay. Now Z transform, our damping rule is this much. So Z transform of un is nothing but this. So when we add a k power n, so it will always be in terms of z by k. So it's nothing but in place of z, you have to apply z by k. These are k. So in the same way, Z transform of k power minus n un using the damping rule is always zk. So these are things. So as you know, there is just k power and there is no k power minus n. So I'm gonna use this. Okay, use this damping rule. So it's nothing but in place of z, I have to apply k power n, right? So in place of z, I have to apply k z by k. That's it. So our damping rule from this Z transform of k power and cos n theta can be written as what? z by k into z by k minus cos theta whole divided by z by k whole square minus 2z cos theta plus 1. Now, by taking the LCM of all 2z by k, now by taking the LCM, I get as z by k into z minus k cos theta by k. Right? Now, whole divided by z square minus 2z cos theta plus k square by k square, because k power whole square, so k square. Now this and this and this and this gets cancelled. Now our final term can be written as, remove this case, so it's nothing but z into z minus k cos theta whole divided by z square minus 2z cos theta plus k square. So this is the z transform of k power n cos theta. So in the same way you can write it the same way as z power t of k power n sin n theta. As you know this here, you have to just substitute z by k and you can further solve it. Okay, so let me know what's the answer in your comment box. Okay, now we got this. Now in the same way, let me erase this whole left topic. Now take this separately. Now e power minus a n cos theta minus a n cos n theta. Right. So how can I write this e power minus a n? Minus a power n is equals to e power minus a whole power n. This is nothing but k power n. So it's nothing but k power n, and using the k power n. So in place of k, where k is equals to e power minus a. That's the same. In place of k, apply e power minus a. In place of k, just apply e power minus a. That will give you the answer. So let the final answer will be for this is z into z minus e power minus a cos theta whole divided by z square minus 2z cos theta plus e power minus 2a. So this is for e power minus a and cos theta. So in the same way you can find it for this also. As in place of whatever you get for sin and theta, this is for cos and this also for cos. For sin you have to, whatever I gave here for sin you have to solve. You have to apply the k power n thing and you have to supply for this. So this is the final for e power minus a n sin theta and k power n sin theta and theta is what you can find it by yourself and can just type it in my comment box. Okay, thank you all. This is a set transform for cos and theta. So what are the main steps you found out here? You have to first find for, let me tell you, the basic steps we gone through all these things. Okay, first we wrote e power I n theta, which is nothing but cos n theta plus sin n I sin n theta, and e power I theta whole power n, we made it as k power n. So we know the transform of k power n. In place of k, I had to substitute e power minus I theta. So after e power I theta, I had to divide and multiply by ez minus e power minus I theta. Okay. So after that, we have to apply the values of e power minus I theta in the numerator. In the numerator, we have to apply the values of e power minus I theta. But in the denominator, you have to multiply it. Okay. So I think you can go through all these things. And this is the last step. So after that, you have to simplify. So as I told you, real and imaginary parts. So I have to convert it to real parts and imaginary parts. So from the real parts, you'll get cos and theta from imaginary parts you will get sine and theta. Okay, so from cos and theta and sin and theta, and then you have to use the damping rule. Damping rule for to find kappa n and kappa n. So after damping rule, you can easily find e power minus 8. So let me know if you have any queries in the comment section, and thank you all for watching my channel. So you can please like and subscribe to my channel.